object, that is, it is data structure and algorithms. First, just try to understand what is the meaning of this data structure. What is the meaning of the term data structure? Now, first, I want to show you one image. You can say one particular picture, and this is a very simple picture. Now, in this picture, okay, now see, there is a picture of a book shelf. Now, in this side, there is a book shelf, but there are lots of books. See, lots of books, lots of different stuffs are there, but they are in a messy order. And it is in a mess-like structure, means all things are in hodgepodge. But in the next picture there, you can see it is in well organized, or you can say in a particular order. So we can say this is organized. Okay, and see, not only organized, there is some tags are added here. See, classics and coloring books. These are picture books. These are chapter books. These are crafty books and few creative toys. So not only the books are in order, but also with some tag. Now, if I ask you to search a particular book, if I ask you to search a particular book in this bookshelf, and then if I ask you to search a particular book in this bookshelf, so it is very obvious, and all of you, means I am giving the answer in behalf of you, that all of you in one term say that it will be very easy to search a particular book in this particular organized bookshelf, rather than in this hodgepodge bookshelf. Clear? Why it is easy to search a particular book in this organized bookshelf? Because it is already tagged. It is already in order. So, if you consider these books as your data, these are different data. These books are what? The books are nothing but the data. And whatever we are doing in today's life, in our IT field, everything is based on data. Okay, so if we can consider that these books are nothing but data, then it is very obvious or easy to say that I can easily search, access, so we can easily search, we can easily access books or data in this ordered self rather than in this messy self. So if my data is in a organized structure, if my data is in a organized structure, then it is easy to access, it is easy to search a particular data. So this is the all motto or goal of data structure. So what is the goal or motto of data structure? The main motto or goal of data structure is to access the data, to access or search the data in an easier way. In this messy data, if I ask you to search a particular data, it becomes very difficult. It is time consuming. But in this organized order, which is, you can say here, data is in a particular structure. So data is in a structure format. So it is very easy to access. So since there is a lot of data in today's life, so we have to make it easier. We have to make the searching, we have to make the access easier and less time consuming to make it more faster. So this is the whole idea about this data structure. So it means you have to make your data in such a order, in such a structure, so that we can easily access them. That is the meaning of data structure. Now, if your data is in a structured form, then it becomes very easy to access. It becomes very easy to search. So we can say if data is in a structured way, we can easily access them. Not only access them, also we can search them. Okay. Now see, these two things are very important in case of any data. Now try to understand one simple example. Suppose I'm performing the operation factorial. So most of we already know how to perform the factorial operation, or what is the meaning of factorial. Now I will discuss the factorial in two different ways. One is the normal iterative way. I hope you have heard this term, iterative way. Another is recursive way. Okay, recursive way. Now, if it is an iterative way, we know that we have to use some for loop, repetition. And if it is recursive way, then we have to call the function itself. So call itself. So this is the basic difference. Normally, if there is any repetition, that can be converted into recursive if there is no interrelation between this recursive calls. Okay. So now, so we know the definition of factorial. If we want to calculate n factorial, the definition, the first the iterative definition, it is 1 into 2 into 3 into like this way up to n. Now, what is the definition of the recursive one? The definition of recursive one is factorial n is equal to n into n minus 1 factorial. That's why it is called recursive call. To know the factorial of n, we have to call the factorial of n minus 1. So factorial itself calling another factorial. That's why it is called recursive. Okay. Now see, so if it is recursive, then if I want to calculate the value of factorial 5, so it will call 5 into factorial 4. So new function factorial 4 is called. Now factorial 4 will call 4 into factorial 3, a new function 3 will be called. Now 3 will call 3 into factorial 2, so a new function 2 will be called. Then 2 will call 2 into factorial 1. Now suppose we know the value of factorial 1, so this is called the terminating condition. Generally, recursive function having a tendency to become infinite. To stop it, we have to give the terminating condition. And here the terminating condition in case of factorial is either n equal to 0 becomes 1 or n equal to 1 becomes 1. You can stop either in value of n 0 or n of 1. So suppose I am stopping it in factorial in value n equal to 1. So when the value of n is 1, we know we have to the value of factorial is 1. So now see, the function is called in this manner. First 4, then 3, then 2, then 1. Now see, which one will be executed first? This one will be executed first. 2 into the value that is 1. So the result will be returned to this factorial function. Now the result will be returned to this factorial function. Then the result will be returned to this factorial function. Then the result will be returned to the final function. See, the calling of the function is in this manner. First 5, then 4, then 3, then 2. But the execution or the multiplication is in this order. Correct? So it is totally a reverse order. It means when I am storing the data in some data structure or organized way, it must be in such a way that it will be able to perform an operation which is like this: last in, first out. Why? See, the last calling function will be executed first. So that's why we need a data structure which will be able to solve or which will be execute in this form, that is last in first out. And the data structure which is applicable for this type of recursive function, where the last function call will be executed first and then the next one and then the next one, we need a data structure. Some of you already know that we need a data structure stack. So now from this example, you can easily understand that why we need different data structures, why we need different organization of structure. See, this is a different type of organization where we are able to access the data in a last in, first out, or first in, last out order. So to access the data, to search the data, we need different types of data structure. So data structure means, now see, now this data structure, whatever I am telling, this is in logical form. This is not in physically. What is happening inside the memory, we have no idea. But we are just assuming that this type of things is happening. Okay, that's why we are assuming, or logically we are thinking that the order of data must be in this last in first. But what is happening inside the memory, we have no idea. That is a hardware part or physical part. But we are assuming. So we can say this is a logical. Okay. Or you can say this is a mathematical way of representation. We are representing the data in a mathematical way or logical way so that we can easily access the data. Clear? So what is the purpose of data structure? The purpose of data structure, again, I am repeating the same thing. The purpose of data structure is access the data in an easier way, in a less time. Okay. And how we can achieve this? By using some mathematical or logical organization. So what is, if anybody asks you what is DS or data structure, remember the definition will be like this. This is some kind of logical, or again, why logical? Because we don't know the physical, how physically it is happening, but we are assuming. So that's why I am telling it logical or mathematical way of representation of data, so that we can easily access them. Okay, so this is the actual definition of data structure. Now, in this definition, one very important thing that you should mention, otherwise this definition will be not perfect. You should mention in which memory we are doing this. Remember, we are doing this in the RAM, not in the hard disk. We are doing all this thing in our primary memory, RAM. If we do this thing in our hard disk, then it will be called DBMS, Database Management System. So there's a very thin line of difference between this DS and DBMS. In case of DBMS, again, we are storing the data in such a way that we can easily access them. But in case of DBMS, we are storing the data in our hard disk. Normally, in our hard disk, data will be stored in a file management system structure, which is actually done by the OS. But if you want to store the data in some organized way in using DBMS, you have to install a third-party software, either say Oracle or say MySQL. So you have to install those type of software. Okay, so but remember, this is happening in our hard disk memory. But if I want to perform data structure, that must be in our RAM memory. So what should be the perfect definition of DS? Logical or mathematical way of representation of data in RAM so that we can easily access them. So this is the actual definition of data structure. Okay, again, so we are doing our data in a structured form. We are storing our data in a structured form in our RAM or primary memory so that we can easily access them. So this is the whole meaning of data structure. So I hope now it is understood that why we need data structure. So this is the main use of data structure. So after now we are storing the data in a structured form. Now we must access them. And how we can access them? We can access them using some steps, some sequence. It is not randomly we are going to access them. We are going to access them following some steps, some sequential instructions. And those sequential instructions, or you can say sequence of steps, to describe some solution for a problem. Now we have some data and we have some problem. Now if I want to, so based on this data, I have to solve some problem. There is some problem on this data. I have to solve this problem. So I have to solve this problem. To solve this problem, I have to write some algorithm or sequence of instruction. Okay. So algorithm is some sequence of instruction to solve a particular problem. Okay. Now, to solve a particular problem, we have different things. I hope you know these things. One is that is called flowchart. Okay. So this is nothing but the pictorial representation of your algorithm. This is pictorial representation of your algorithm, or you can say your sequence of steps to solve the problem. So pictorial representation of the algo. Okay, there is obviously there is algorithms. Okay, and there is another thing which is sometimes very important, which is called pseudocode, or you can say code. So there is a basic difference between code and pseudocode. Basically, code will be written using some following some structure, following some language, either C or Java. But there is another concept which is called pseudocode, which is intermediate between this algorithm and code, which is intermediate between this algorithm and code. Okay, and those pseudocode are not follow some particular rules, not follow some rule of language, but code must follow some rules, or it must be according to some language. Obviously, some high level or low level, it depends. Okay, so if I say what is algorithm, the definition is pretty clear, that a sequence of steps which will solve a particular problem. Okay. Now, when we are writing some algorithm, we have to follow some rules, or for a particular algorithm, there is some characteristics. Okay. Now, the characteristics that we must follow in case of any algorithm. So, I'm not going to define algorithm because it is already known to you. So, but if you define it, you can define it like this: sequence of steps to solve a particular problem. Okay, you can say that this is algorithms. Okay, now this algorithm should have some characteristics. What are those characteristics? Remember, these characteristics are very important. Now, the characteristics are, number one is, you say, finiteness. Finiteness. Now, what is the meaning of this? It means that your algorithm must be finite. It is not, suppose you are using some for loop or repetition in your algorithm, and that for loop is running infinite time, that is not expected. Okay, so your algorithm must be finite. It should stop after some specific steps. So that is very important characteristic in case of any algorithm. It must be finite. Okay. Then it must be, uh, uh, you can say, definiteness. What is the meaning of this? Now, suppose in your algorithm, you are using some words which having some ambiguous meaning. Now, what do you mean by ambiguous meaning? Suppose I'm using a term bank. Suppose I'm using the term or word bank in my algorithm. Now, see, this bank having two different meanings. Correct? One is it can be used as a river bank, side of the rivers, and it can be used as a bank which store our valuables, money. So this bank having two different meanings. So we can say this is one ambiguous word. So in your algorithm, there should not be any ambiguity or ambiguous words. It must be definite. Its meaning should be definite. Okay, so that's why it is called definiteness. So algorithm must be finite. It might have some words or meanings which have some definiteness. Then each and every step of the algorithm must have some effect. It should do something. Suppose I am writing, take some input. So it should do some input taking operation. Then suppose I am saying add two numbers. It should do some adding operation. So that's why it is called each and every step should have some effect on the output, on the operation. So that's why it is called effectiveness. So your algorithm must be effective. Okay. Now the next thing that is very important, your algorithm should have some input. Now you can say, suppose, for example, suppose I want to calculate the factorial of a particular number. So for taking the factorial value of a particular number, I have to take some input. Now you can do it like this, that you have already defined some value inside your program. So there is no scope of taking input. So there may be some algorithm where there is no input. Clear? So this is another thing, and you remember zero input is also allowed. Okay, but normally for your algorithm there must be some input. And the next thing is very important, your algorithm should have some definite output. After performing so many things, you are going to solve some problem. So you should print something. You should give some output, definite output from the algorithm. Okay. And the next thing is that is generality. Now, what is the meaning of generality? Generality means your algorithm must be having some general idea. Suppose you are going to add two numbers. Add two numbers. Now, these two numbers may be integer or may be float, whatever. You will add them. That is called the generality. So, your algorithm should have these 6 characteristics. If you don't follow these characteristics, your algorithm will be considered as an incomplete algorithm. So again, a sequence of steps with finiteness, with some definiteness, with some effectiveness. It should have some input, definitely must have output, and it must be general. It can be used, means shorting. It can short integer, it can short float, it can short anything. That is called the algorithm. And then we can say if it is able to solve any problem to short, then we can say that my algorithm is general. So these are the very interesting characteristics for any algorithm. Okay. Now we already know that for a particular algorithm, there must be different you can say different solution, sorry, for not algorithm, for a particular problem you can give different solutions. Solution 1, you can give another solution, solution 2, you can give another solution, solutions 3. So for a particular problem there must be different solutions. Now the question is, among this solution, which one is best? Okay, to decide which one is best, you have to take some parameters. You have to consider some parameters. Based on these parameters, you can say which solution is the best. And those parameters are, one is called time complexity, or the time required to solve a particular problem, and another is space complexity, or the space required to solve that problem. So these are the two parameters. Based on these two parameters, we can decide, or we can say that this solution is the best. Okay, now again, it depends. When I'm telling you that time complexity and space complexity, again, it depends which one you will prefer. Will you prefer the less time, or you will prefer the less space? So again, it depends. So, but based on these two parameters, time complexity and space complexity, you can easily decide which one is the best solution. So for a particular problem, you can write different algorithm. So in practical example, suppose I want to go from Calcutta to Delhi. I want to go. Okay. Now I can go from Calcutta to Delhi by only walking. Just I am using walking. I can go by, say, one vehicle, or say some taxi. Okay, so this is suppose one taxi. I can go using train. I can use train also. Okay, I can use flight. Okay, so these are the different way I can reach to Delhi. See, if I go by walking, it will take maximum time, but my cost, so the space, if you consider space as my cost or money, then the cost will be the minimum, but I will require the maximum time. If I go by some car, then my time will be saved, but I have to spend some money. If I go by train, more time will be saved, but I have to pay some less money rather than this car travel. But if I go by this plane, it will minimize my time, but it will maximize my cost. So if we consider time complexity and another cost or space complexity, then for a particular solution, for a particular problem to reach, so here the problem is to reach from Calcutta to Delhi. Now there are 4 different solutions. Among the solution, if you consider time, I want to save time, then the best solution is this one. But if you say I want to save space or cost, then this one is the best solution. Logic clear? So again, it depends on your choice. Which parameter you want to give more preference. Okay, based on that, there will be different solution, and based on that, among this different solution, one of them may be best. Okay, so from this practical problem, again, we are going to solve one interesting problem that we already know, that the problem is called prime number, whether a given number is prime or not. So this is a very interesting problem. So for this prime number, so first I'm giving one solution what is the definition of prime number? The definition of prime number is it is only divisible by 1 and the number itself. It is only divisible by 1 and the number itself. It means if I divide a given number n using these values from 1 to n, say this 1 to n is represented by I, it will, if in all these cases, only it is divisible by 1 and n only, then we can say that this is a prime number. Okay, so if you write it, it will be like this: for I equal to 1, I less than equal to n, I will be increased by 1, and then what I am doing, I am checking whether it is divisible or not. N modular division I not equal to 0. If it is not equal to 0, then I am taking a count of how many times it is not divisible. Okay, or you can say, sorry, you can do it in reverse order also. Sorry, not in this order. So in this case, it is only divisible twice. Na? If it is a prime number, it will be only divisible by 1 and n. It means only divisible twice. So if n modular division I equal to 0, and if I take a count how many times it is divisible, and let the count is starting from 0, and finally if I check whether this count value is 2, then I can say it is a prime number. Logic is clear? So this is the basic definition of prime number. The prime number is only divisible by 1 and the number itself. Only it means if I divide it from 1 to n, then it will be only divisible twice. That's why I am making a count how many times it is divisible. If it is divisible only 2 times, then I can say that the number is prime. Okay, so this is one solution, the easiest solution. Now the next solution is from the basic definition of this prime, what we are saying that it is only divisible by 1 and n. So from that definition, I can say that it is not divisible by this. What are inside this circle? Inside the circle, it is 2, 3, then dot 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 up to n minus 1. So now the definition is in a reverse form. It is only divisible by 1 and n. So its reverse form is it is not divisible by 2 to n minus 1. 2 to n minus 1. It is not divisible. So reverse form of this actual definition. If I implement this, again, we can easily implement this. So my for loop will run from I equal to 2, I less than n, correct? Here it is up to equal to n, now less than n because I have to check up to n minus 1, okay? Then I plus plus, then according to that you have to write your code. I'm not going to write that code because here this thing is very important. How many times I am checking, how many times I am repeating the thing, that is very important because this will help me to calculate the exact time required. Okay, that's why I'm calculating this part. Okay, similarly, from this to definition, we can again further improve the definition by doing this. What I'm going to do, the next definition is, since it is so the definition is if a number is not divisible by a particular value, then it is definitely not divisible by its double. Suppose it is not divisible by 3, then it is not divisible by 6. If it is not divisible by 5, then definitely it is not divisible by 10. Okay, so no need to check up to n minus 1. Instead of that, we can stop only in n by 2. Okay, so now the for loop become like this. Again, we are modifying this one. Okay, so for loop will modify to I less than n by 2 I plus plus. Okay, so this is another solution. Now again, there is another solution, very interesting. If a number is not divisible by 2, then definitely it will not be divisible by its square. If it is not divisible by 2, then definitely not divisible by 4. If it is not divisible by 3, definitely not divisible by 9. So square. So if I modify this algorithm, then it becomes 2I less than equal to square root. So no need to go up to that square value. We can check up to square root value of n. So this is another solution. So for prime number checking, there are 4 different solutions. Okay, now which one is best? Now remember, when there is a two different things or two different parameters, one is the time complexity and another is the space complexity, we give more emphasis on time complexity because time is still 24 hours, but the space nowadays, space is not that much bound. Why? Because in our time, it is 2000 when I bought my first computer PC, then I have only 128 MB RAM. You can understand the size of the RAM. 164 or suppose more or less 164 MB. And now the minimum RAM size in our desktop or laptop is 4 GB. So space is not that much important nowadays, not a hindrance, you can say. But time is still 24 hours. So time complexity is more powerful. So that's why we take or we give more emphasis on time complexity. Okay, so there is only a few seconds left.